January 1981. Houston, Texas. Conexpo, the largest construction equipment trade show in the Western Hemisphere. Komatsu wheels out a prototype, a Bulldozer, 1,000 horsepower, 120 metric tons. It is the biggest dozer anyone in the building has ever seen. The crowd is impressed. The press takes photos. Komatsu calls it the D575A. Then the global economy collapses, and the machine sits in a warehouse for 8 years. When it finally reaches production, Komatsu builds a bigger version, 1,150 horsepower, 336,000 pounds. A blade taller than an NBA center moves 90 cubic yards of earth in a single pass. It becomes the largest production bulldozer ever manufactured. They call it the D575A. In 30 years, they sold 53. Every single one was built at a loss. The project started in 1977. Komatsu wanted a machine that could dominate the ultra-large dozer class in surface mining. At the time, Caterpillar's D11 line owned that market. The D11 was proven, established, and everywhere. Komatsu's own D475A held roughly 35 to 40% market share against it. Not bad, but Komatsu did not want to compete with the D11. They wanted to make it irrelevant. The concept was simple. Build something so large, so powerful, that no competitor could match it. Not a better version of what existed, a new category entirely. The D555A prototype was completed in 1980 at Komatsu's facility in Osaka, Japan. It made its public debut at Conexpo in January 1981. 1,000 horsepower, 120 metric tons. It had a blade capacity of 69 cubic meters, the largest bulldozer on the planet. Then the mining sector collapsed. Commodity prices dropped through the 1980s. Orders for heavy equipment dried up worldwide. Nobody was buying standard dozers, let alone experimental ones. The D555A never entered production. One prototype. That was it. For most of the decade, the project sat dormant. The engineers moved on. The prototype collected dust. Inside Komatsu, the superdozer was a finished idea that never found a market. In the late 1980s, the mining economy recovered. Komatsu pulled the project back out, and they did not restart the D555A. They redesigned the entire machine from scratch, making it larger and more powerful than the prototype. The result was the D575A2 Super Ripper. Field testing began in 1989 with the Cooney Brothers Coal Company in Pennsylvania, where the prototype logged over 1,000 hours. Full production started in 1991 out of the Osaka plant. The first production machine was built up by Anderson Equipment Company and sold to American Asphalt and Paving in Las Vegas. In 1995, the superdozer variant followed. The first one went to Princess Beverly Coal Company in Cabin Creek, West Virginia. The specs were staggering. A 12-cylinder Komatsu diesel engine produced 1,150 horsepower. The superdozer configuration weighed 336,000 pounds. It stood 16 feet tall and 38 feet long. The blade stood nearly 12 feet high and stretched over 24 feet wide. It could move 90 cubic yards per pass with the standard blade and 125 cubic yards with the optional blade. That moved roughly 720 wheelbarrow loads in a single push. The single shank ripper could tear into the earth to a depth of 6 feet 9 inches. This was not a machine you drove to the job site. To move a D575A between locations, crews had to disassemble it into components and load everything onto 6 to 8 flatbed trucks. Between 1991 and 2000, Komatsu built 41-2 machines. 31 went to North America, 14 to Australia, and 8 to Japan. In Australia, Alcoa purchased 5 super rippers for bauxite mining near residential areas where blasting was prohibited. Those machines ripped rock by remote control. In West Virginia, 17 D575As worked the coal fields at one point, mostly for Alpha Natural Resources and Princess Beverly Coal. 2 second-hand units eventually made it to New Zealand's South Island, where they ripped overburden at the Stockton coal mine, sometimes operated remotely above abandoned mine shafts too dangerous for a human to sit on. Then Komatsu updated the line. The D575A3 launched in 2001. New electronics, the Palm Command control system, an upgraded cab, and better displays. Most of the improvements were digital. The timing was terrible. Coal prices had dropped around 2000. The mines that bought D575A units could not afford new ones. Between 2001 and 2007, 11 machines were ordered in total. Then the 2008 financial crisis hit. Between 2007 and 2011, Komatsu received 0 orders. Here is the part the brochure never mentioned. The D575A was sold at a loss on every unit. Manufacturing costs were far higher than the market price could support. The logic was straightforward. The D575A produced roughly twice the output of Komatsu's D455A. So in theory, it should cost about twice as much. In practice, the production costs were significantly more than double. Komatsu absorbed the difference because broader dozer sales across the product line were strong enough to cover it. The D575A was a flagship, a proof of concept, a statement that Komatsu could build the biggest dozer on Earth. But it was never profitable. And there was a deeper problem. Every D575A order pulled workers off the assembly lines that built Komatsu's better-selling D375 and D475 models. The same staff built all 3 lines, so each time a D575A order came in, it slowed production of machines that actually made money. When something broke on a D575A in the field, and things did break, Komatsu dispatched specialists to the customer's site. They diagnosed the problem, made repairs at Komatsu's expense, then revised the engineering drawings so the next machine would not have the same issue. Sometimes replacement parts had to be cast from scratch and shipped to the other side of the world, causing weeks of downtime. The D575A was not just unprofitable to build, it was expensive to support. Through all of this, Komatsu held on. In Osaka, the factory kept the drawings, the manufacturing jigs, the molds, the specialized tooling. The D575A was still their flagship. Internally, they called it their star of hope. They believed the orders would come back. In 2012, Alcoa in Western Australia placed a custom order, one more D575A3. It was the 53rd machine and the last one Komatsu ever built, serial number 10112. After that, the Osaka plant asked management what to do with the tooling that was taking up floor space. The jigs had rusted. The molds did not work like they used to. New emissions regulations would require an expensive engine redesign to continue production. Komatsu made the call. They discontinued the D575A and retired all manufacturing resources. One detail almost nobody knows. Komatsu assigned serial numbers 10,001 through 10,043 for the -2 machines, and 10,101 through 10,112 for the -3 machines. But 2 serial numbers were never used, 10,004 and 10,013. In Japanese culture, the number 4 is pronounced shai, the same word as death. 13 is considered unlucky for the same reason it is in the West, and there is added weight because 4 plus 9 equals 13, and 9 is pronounced Q, the word for suffering. Komatsu skipped both numbers. They built the largest bulldozer in history and would not stamp it with a number that sounded like death. Today, most D575As have been scrapped or sit idle. 2 are preserved in New Zealand. One is at the Ross Brothers Museum in Cambridge on the North Island. Another stands at the entrance to Caterpillar Quarries' Brookby Quarry. In Japan, a few still work in quarries owned by Fujisako. Caterpillar's D11, the machine Komatsu built the D575A to surpass, is still in production. It has been updated, refined, and sells steadily. The D11 did 80% of the work at a fraction of the cost, and mines could actually get parts for it. The Komatsu D575A was not a failure of engineering. The machine worked. It moved more earth per pass than anything else on tracks. It ripped rock where blasting was banned. It operated by remote control in places too dangerous for operators. But Komatsu built a machine the market did not need enough of. 53 units in 30 years. Everyone sold at a loss. The tooling rusted in a factory that waited for orders that never came. They called it their star of hope. Then they scrapped the molds and moved on. If this is the kind of story you are here for, subscribe. We cover the machines that worked, failed, or quietly disappeared. The engineering was real. The economics told a different story. More coming soon.